Hello everyone, good morning. I am Nikon, your physics faculty from QNI, and I welcome you all to the QNI class. How are you all? Okay, so today we will start with the graphs. Okay, so mainly today we will discuss about graphs, but before starting the lecture, first we will see what are the prerequisites. So first one is basic mathematics. Okay, second is distance and displacement, then speed and velocity. Okay, and then acceleration. So these are the prerequisites for today's lecture. Okay. I hope everybody knows what is distance, what is displacement, speed, velocity, and acceleration. Any doubt in any topic?
Sir, I have a doubt, sir.
Okay. Now, if we talk
Even
about
I
the
have doubts, sir.
yes, tell
Sir,
me.
what is displacement? I forgot.
Displacement is the shortest distance between 2 points. Shortest path.
Okay, okay, sir.
Okay. Any other doubt? Okay. Now, if we talk about the weightage, so from this chapter, approximately 7 to 8 marks question asked. And what we are going to cover today. So first we will study about basic concept of graph. Then we will see distance time graph for uniform motion. After that, we will see distance time graph for non-uniform motion, velocity time graph for uniform motion, velocity time graph for uniformly accelerated motion. Okay. So these are the today's topics. So let's start the lecture with the graphs. Okay. So you can see there is a graph. So there is x-axis and there is y-axis. So first thing come in our mind that what quantity should be taken in x-axis and on y-axis. Okay. So basically on x-axis and y-axis we have two variables. Okay. We have two variables. Okay. So variables are independent and dependent variable. Variables are independent and dependent variables. Independent variables and dependent variables. Okay, so anyone having any idea what is independent and dependent variable? What is independent and dependent variable? Any idea?
Sir, I think dependent variables means they depend upon something.
Okay, and what are independent variables?
Who doesn't depend on someone or something like that. Like
Okay,
opposite of dependent.
okay, let me give you a equation. Suppose we have a equation y is equals to x plus 1. Okay, so here we can say that y is depending upon the, here we know that y and x both are the variables. Yes or no? Here in this equation, y and x both are variables. Okay. Now x can take any value and depending upon the value of x, y will change. Yes or no? Depending upon the value of x, y will change. That means y can take any value and basis of that value, accordingly y will change. Suppose if x is equals to 1, then if x is equals to 1, then y is equals to 2. Similarly, if x is equals to minus 1, then y is equals to 0. And if x is equals to 0, y is equals to 1. So here we can see that x can take any value and accordingly y will change. So here we can say that x is the independent variable and y is the dependent variable. Clear? You can also rewrite this equation as y is equals to x plus 1. Now can we write this as x is equals to y minus 1? Yes or no? Are we clear till now? Any doubt?
Clear, sir, clear.
Kevin, your voice is very low. Kevin, your voice is very low. Okay. Now here again y is independent, sorry, y is independent variable and x is dependent variable. Here y can take any value and accordingly x will change. Suppose if I take y is equals to 2, so if we put y is equals to 2, so 2 minus 1 becomes 1, so x is equals to 1. Now if we take y is equals to 0, so if we put y is equals to 0, then x becomes minus 1. Similarly, if we take y is equals to 1, so x becomes 0. So you can see both side, for both the equation, values are same. For x is equals to 1, y is equals to 2. For y is equals to 2, x is equals to 1. So both are correct. Here I am telling only about the what is independent and what are dependent variables. So independent variables are those which can take any values, and dependent variables are those which are depending upon the independent variable, and the value of independent variable, sorry, the value of independent variable change accordingly on the basis of dependent variable. So are we clear what are independent and dependent variables? Any doubt to anyone? Kevin,
Sir.
Samanga, Kamalan, any doubt to anyone?
No, sir.
Okay. Now, quantities which we take on x and y axis. So which quantity we take on x axis, which quantity we take on y axis, or we take dependent or independent variables on x axis, what we take on y axis, independent or dependent variable. So generally we take x axis, generally we take independent variables on x axis and dependent variable on y axis. Generally, okay. Generally we take independent variable on x axis and dependent variable on y axis. Yes or no? Yes or no? You can take dependent variable on x axis and independent variable on y axis, which is absolutely correct. But generally, for easiness, we take independent variables on x and dependent variable on y. Okay? Is this clear to everyone? Yes or no?
Sir. Yes, sir.
Okay. Now, if we talk about the distance and time, can you tell me time is independent or distance is independent? We say distance is changing with respect to time. That means time is independent and distance is depending upon time. So can we say that distance is dependent variable and time is independent variable? Very good, Kamala. Very good. Okay. So if we talk about distance time graph for uniform motion, so suppose we take several values for starting at the starting of motion, that is at 0 second. Let's say distance covered by the body is 0. Now after 5 seconds, distance covered by the body is 7 meter. Another after 5 seconds, distance covered by the body is 14 meter. Another after 15 seconds, distance covered by the body is 21. Similarly, these are the values. Okay. So we fill the data here. Now we plot this distance and time values on the graph. Okay. So here we take graph. This is our x-axis. This is our y-axis. Now which quantity we take on x-axis? Tell me. Which quantity we will take on x-axis? It's time or distance?
Time. Time,
Time.
sir.
Very good. So we'll take distance on y-axis. Okay. Because time is independent and distance is dependent variable. Clear? Yes or no? Clear? Okay. Now if we plot these values on the graph, so see here, at this is our origin 0, 0. Now on x-axis we take time, on y-axis we take distance. Okay. Now if we plot this value, so initially at 0, 0, we are at 0, 0. Okay. Now after 5 seconds, we cover the distance of 7 meter. Okay. Similarly, if we plot all the values given in the table, so we will get these points. Yes or no? Yes or no? For different values of time, we have different values for distance covered. Okay. Now, if we join all these points, we will get a straight line. Yes or no? We will get a straight line. So anyone can tell me which type of motion is this? Uniform motion or non-uniform motion? Now, what is the meaning of uniform motion? If a body covers equal distance in equal interval of time, we call the motion is uniform. And if body covers unequal distance in equal interval of time, we call motion as non-uniform. So can anyone tell me this is uniform motion or non-uniform motion? Uniform motion, very good. So for uniform motion, the distance time graph is a straight line. Yes or no? Distance time graph is a straight line. Yes or no? For uniform motion, distance time graph is a straight line. Okay. Okay. So the graph is a linear graph. Okay. The graph is a linear graph. So the straight line in the distance time graph shows that the distance is increasing with time. Yes or no? Can we say initially body is at origin, then after 5 seconds body is at 7 meter, after 5 seconds body is at 14, after 5 21, then 28, then 35. Can we say with respect to time distance is increasing? Yes or no? With respect to time distance is increasing. Yes or no?
Yes, sir.
Okay. So here you can see we can say that body is in uniform motion. Body is in uniform motion. So remember these points that generally on x-axis we take independent variable and on y-axis we take dependent variable. And for uniform motion, the graph is linear. That means it is a straight line. Yes or no? All things clear to you that what are the independent variable, what are dependent variable, what is the nature of the graph for uniform motion? Yes or no? Okay, very good. Now, if we want to find the velocity of the object for the given graph, so we have given distance time graph, okay, for different interval of time, for different time, we have different distance covered. Okay, now we want to find the velocity. So can anyone tell me? Okay, first tell me what is velocity? What is velocity? Tell me what is velocity? We already studied in the previous classes about velocity. Kevin, what is velocity? Shubhranshu, Kamalan, what is velocity? The rate of change of an object position over time. No. So Magana, I'm talking about velocity, not speed. Both are different quantities, yes or no? Speed is scalar, velocity is vector. Speed is distance covered upon time. Velocity is displacement upon time. But if body is traveling in a straight line without changing the direction, in that case we can say that distance is equals to displacement, and in that case we can say that speed is equals to velocity. Now here we know that velocity is rate of change of position, or we can say displacement upon time. Okay. Now if we talk about 2 points, that is A and B. Okay. So we know that at A time is 5 seconds and distance covered is 7 seconds. Similarly, for point B, time is 10 seconds and distance covered is 14 seconds. Yes or no? So can anyone tell me that what is the displacement from A to B? What is the displacement from A to B? What is the displacement from A to B? That is, what is displacement? Final position minus initial position. Displacement is final position minus initial position. Finally, body is at point B, and at B, the distance covered by the body is 14 meter. Yes or no? And initial position is point A, and at point A, body is at 7 meter. Yes or no? So can we say here that displacement is 7 meter? Yes, 7. Very good. Now, what is the time taken by the body from A to B? If body is going from A to B, then what is the time taken from A to B? 5 seconds, 10 minus 5. Yes or no? Very good. So what is velocity here? What is velocity? Now we know that time is equals to 5 seconds. So can we say that velocity is nothing but displacement upon time, that is 7 by 5 meter per second? Yes or no? Okay, let's try another one. Suppose body is going from point B to point C. Now tell me what is the velocity? Now we want to find the velocity for the interval from B to C. So everyone please tell me what is the velocity from B to C? Is it same or different?
The same, sir. 7/5.
Why? Why is it same? Because the body is under uniform motion. Yes, very good, Kevin. It is covering equal distance in equal interval of time. That means, and body is under straight line. So can we say velocity is constant? Yes or no? So for every time interval, that is from A to C, from B to C, okay, anywhere from A to E, everywhere speed is 7/5 meter per second. Okay. Now let's say I'm saying that here coordinates are x1 comma y1. Coordinates are x1 comma y1. At 5 comma 7, I'm saying coordinates are x1 comma y1, and at B I'm saying coordinates are x2 comma y2. Yes or no? Yes or no? Here x is what? X is time. X is representing time and y is representing distance. Yes or no? Here x is representing time, y is representing distance. Are we clear till now? Anyone having any doubt?
No, no, sir.
Okay. Now, if we want to find the displacement, can we write, sorry, if we want to find the velocity, so velocity is equals to displacement upon time. Now we know that distance is represented by y coordinate. Okay. Yes or no? Here distance and displacement are same. Why? Because body is traveling in a straight line without changing the direction. Okay. So can we say that distance is nothing but y2 minus y1 upon time is nothing but x2 minus x1? That is final minus initial. If I'm talking about from A to B, so B is the final position, A is the initial position. Can we say that final minus initial is what? Y2 minus y1 is displacement, x2 minus x1 is time. Yes or no? Now put the values. So y2 is nothing but 14, y1 is 7, x2 is 10, and x1 is 5. So this is equals to 7/5. And this we called slope. What we call this as? Slope. So slope is nothing but y2 minus y1 upon x2 minus x1. What is y and what is x? So the quantities which we take on x-axis are represented by x1, x2, x3 and so on. The quantity we take on y-axis is represented by y1, y2 and y3 and so on. Okay. Now what is slope? So change in y coordinate upon change in x coordinate. Yes or no? Change in y coordinate upon change in x coordinate. Are we clear till now? So you can use this formula directly. Okay, suppose I'm asking that velocity, what is the velocity if body is going from A to E? What is the velocity if body is going from A to E? Now if body is going from A to E, let's say coordinates is x3 comma y3. Okay, now we know that slope is nothing but slope is y upon x, change in y upon change in x. Now if we talk about y, so finally body is at point E, so final coordinate is y3, initial is y1. Yes or no? Upon change in x. Now for point E, x3 is, and here is x1. Now put the values. Y3 is equals to 35. Okay, minus y1. Y1 is 7. Okay, upon x3. X3 is 25. Upon x1 is 5. Now 35 minus 7 is equals to, tell me, 28
28.
upon 20. Now if we cancel this by 2, so 2 into 14 upon 2 into 10, again cancel by 2, 2 into 7, 2 into 5. Again the answer is 7/5, which is correct. Yes or no? So is distance time graph for uniform motion is clear to you? So distance time graph for uniform motion is a straight line. Okay. Now from distance time graph we can find the velocity. Now slope of the graph will give us the velocity. Now what is slope? So slope is change in y coordinate upon change in x coordinate, that is y2 minus y1 upon x2 minus x1, where y2 is the final coordinate, y1 is the initial coordinate. Similarly x2 is the final coordinate, x1 is the initial coordinate. Okay, so from distance time graph you can find the velocity or speed. Okay, any doubt to anyone till now? Anyone having any doubt? Kevin, Subhanshu, Kamalan, anyone any doubt?
No doubt,
No,
sir.
sir.
Very good. Now we will talk about distance time graph for non-uniform motion. Now what is non-uniform motion? If body is covering unequal distance in equal interval of time. Okay, again we have data. Okay, let's say again body is starting initially, that is at 0 second, body is at origin, that is at 0. Okay, now let's say we have taken equal time interval 0, 2, 4, 6, 8, everywhere the interval is of 2 seconds. Okay, now let's say at 2 second body covering a distance of 1 meter, after 2 second body is covering a distance of 3 meter. Okay, here the difference is 3, here difference is 5, here you can say difference is 7. Okay, so for different interval of time we have different value for the distance covered. Now we want to plot the graph. Okay, so again we have taken x-axis and we have taken y-axis. Now we know that on x-axis we plot time and on y we take distance. Yes or no? Clear? Now we plot the values. So we have taken time here on x-axis, distance on y-axis. Now initially body is at 0, 0, then body is at 2, 1, then at 4, 4, then 6, 9. Okay, so similarly we take all the values on the graph. Now can you connect these dots by straight line? Can we connect these dots by a straight line? Yes or no?
No, sir.
No. That means this is not a linear graph. Okay, so we can connect this by a curve. Okay, you can see there is a curve. Yes or no? Yes
Yes,
or
sir.
no?
Yes, sir.
Okay, so the graph nature is non-linear. Okay, now here you can't find the velocity. Okay, you can't find the velocity, but you will study this in higher classes. We will find the slope, which is nothing but tan theta. So this we will study in the higher classes. Only we know that for linear graph, that slope is nothing but change in y upon change in x coordinate. This is for linear graph. Okay, okay. So here we can say the graph is non-linear. Now this graph also shows that distance is increases with time, but here the increase is not uniform. Sometimes distance covered by the time interval is more, sometimes it is less. Okay, so there is a random increment in the value. We can say the body covers unequal distance in equal interval of time. Okay, the body is covering unequal distance in equal interval of time. Are we clear here for non-uniform motion?
Yes, sir.
Okay, very good, very good. So this graph is for non-uniform motion. Okay, now we will see the velocity time graph for uniform motion. Okay, now again, anyone can tell me on y-axis what we take, velocity or time? On y-axis what we will take, velocity or time? Okay, velocity, very good. Okay, now we have different values of time, we have different values of velocity. Okay, suppose a body is going from A to B. A body is going from A to B. So can we say from A to B, velocity is same, that is 50 meter per second, because from A to B, body is going in a straight line. Yes or no? Which is a horizontal line parallel to time axis. Horizontal line parallel to time axis. Can here we say that velocity is same or velocity is constant from A to B? Yes or no? Okay. Now if we see the coordinates of B, so here let's say time is 3 seconds and speed is 50 meter per second. Okay. So here velocity is 50 meter per second and time taken by the body is 3 seconds. Okay. Now if we want to calculate that how much is distance covered by the body in going from A to B. Now we know that from A to B speed is constant and we know that speed is equals to distance upon time. We want to find the distance. So distance is equals to simply speed into time. Why we are using this formula? Because from A to B speed is same. So speed from A to B is 50 and time taken by the body from A to B is 3 seconds. So the distance covered by the body is nothing but 150 meter. Okay, clear? Yes or no? Anyone having any doubt? Yes or no?
No, sir.
Okay. Now let's say body is again going from B to C. Now coordinates for B to C is 6, 50. Okay, here the time is 6. Okay, here the time is 6. Now if we want to find the distance from B to C, so can we say that distance from B to C is nothing but speed into time? Again, from B to C, speed is same, which is 50 meter per second. But the time taken by the body from B to C, here C is at 6 seconds and B body is for 3 seconds. So 6 minus 3 is 3. Again, this is 3. So this is 150 meter. So can we say that distance covered by the body from B to C is 150 meter? Now we want to calculate if body is going from A to C. If body is going from A to C, what is the distance covered by the body? Again saying that distance is equals to speed into time. Now from A to C, speed is 50, but the time taken by the body is from 0 to 6, that is 6 seconds. So this is equals to 300 meter. Okay. So total distance covered by the body from A to C is nothing but 300 meter. From B to C it is 150 and from A to B it is also 150. Okay. So again here velocity is 50 meter per second. Time taken by the body is 6 seconds. Okay. So distance up to C is nothing but 300 meter. Distance up to C. Why? Distance is equals to velocity into time and velocity is same from A to C. Okay. So this is the analysis we done previously. Okay, from A to B distance is 150 meter, from A to C distance is 300 meter. Now if you want to calculate distance from B to C, simply we can say 300 minus 150. Total is 300. This much is 150. So here this distance is simply distance covered by the body from B to C is nothing but distance from A to C minus distance from A to B, which is 300 minus 150, which is equals to 150 meter. Okay. Now, can anyone tell me, okay, we know formula that speed is equals to distance upon time or distance is equals to speed into time. Okay, from this formula, we get the values, we get the distance covered by the body. Can anyone tell me the any another method that we can directly, without using the formula that speed is equals to distance upon time, we can calculate the distance covered by the body from the graph? So everyone see here that again the given the velocity time graph for the uniform motion. Now we will find the distance by the graphical method. Now we'll find the distance by the graphical method. Okay, we know that this coordinates are at B 3, 50, at C 6, 50. Okay, again if we calculate the area, of B, C, D and E. So B, C, D and E is a rectangle. Okay, what is the area of this rectangle? Tell me. What is the area of this rectangle? What is area of rectangle? Length into breadth? Yes or no? Area of the rectangle is length into breadth. Now what is the length? Tell me. Tell me. Kamalan, Subhanshu. Area of this rectangle. So can we say this length is 6 minus 3 is 3 meter? This is nothing but, sorry, 3 second. Okay. And this height is nothing but 50 meter. Yes or no? Simply length into breadth 2500. How? Beta, this much is 3 second. Now this length is 3 second. Total is 6. This much is 3. So this is 3. Now this is 50 meter. So simply length into breadth. Area is equals to length into breadth for rectangle. Now this is 50 meter into 3 second. Yes or no? Tell me. Sorry, this is velocity 50 meter per second. Okay. So this is equals to 150 meter. Is this clear to everyone or any doubt?
Clear, sir.
Okay. So here area is nothing but 150 meter. Now we calculate previously that here the distance covered by the body from B to C is nothing but 150 meter. Here we are using the formula that speed is equals to distance upon time. So without using the formula by graphical method, we can directly find if we are given velocity time graph. So can we say that area under velocity time graph gives us the displacement covered by the body or distance covered by the body if body is traveling in a straight line without changing the direction? Yes or no? If body is traveling in a straight line without changing the direction, in that case we can say that distance is equals to displacement. Yes or no? And here area under velocity time graph, area under velocity time graph will give us the distance or displacement covered by the body. Yes or no? Yes or no? Here we simply calculate the area, na? So if we calculate the area, we get the distance covered by the body. Yes or no?
Yes, sir.
Okay. So you can see here BCD is a rectangle. So distance covered by the boy is equals to area of the rectangle. Now we know that area of the rectangle is nothing but the length into breadth. Okay. So this breadth is 3 second and this length is nothing but 50 meter per second. Okay. Now put the values, we get 150 meter. Very good. So anyone, any doubt?
No,
Anyone
sir.
having? Okay.
No, sir.
Very good. Now we'll see the velocity time graph for uniformly accelerated motion. Okay, so let's say given that changes in the velocity of a car at a regular interval of time are given in the table, we have to draw the velocity time graph. Suppose values are given in the table that for different time, what is the velocity of the car? Okay, initially speed of the velocity of the body 0 meter per second, after 5 second velocity is 8, another after 5 second velocity is 16. So for different interval of time we have different values of velocity. Okay, now if we plot the graph, x-axis, y-axis, on x we take time, on y we take velocity. Okay, given are the values here. Okay, now initially body at 0 comma 0, then after 5 second it is at 5 comma 8. Similarly we take all the values on the graph. Okay, now if we connect this graph, again we get a straight line. Now can anyone tell me by observation what is the meaning of a straight line here? That velocity time graph for uniformly accelerated motion is a straight line. Now what is the meaning of uniform acceleration? That acceleration is constant. That when velocity is increasing with respect to time. Yes or no? Velocity is increasing with respect to time. For distance time graph, for uniform motion in distance time graph, we get again we get straight line. Yes or no? We get straight line. But for uniform motion in a distance time graph, we get a straight line. But for non-uniform motion, we get a curve. Yes or no? But we also know that for a straight line in uniform motion for distance time graph, slope will give us the velocity. Slope will give us velocity. Yes or no? Here again, that acceleration, if acceleration is uniform, that means velocity is increasing with respect to time. but the increase is linear. Here graph is a straight line, which is a linear graph. Okay, everybody can see here that for all accelerated motion, for uniformly accelerated motion, the velocity time graph is a straight line. This is very important, that for uniformly accelerated motion, the velocity time graph is a straight line. Okay, now for non-uniformly accelerated motion, the velocity time graph can have any shape, according to the variation in the velocity with respect to time. Okay, if motion is non-uniform accelerated, sometime acceleration is 1 meter per second square, sometime it is 2 meter per second square. Okay, sometime it is minus 3 meter per second square. Okay, that means velocity is increasing sometimes at faster rate, sometimes at lower rate. Okay, sometimes velocity can decrease, sometimes velocity can increase. So anything can happen for the case of non-uniformly accelerated motion. Okay, so we can have here, you can see the velocity is decreasing with respect to time. Here first velocity is increasing, then decreasing, increasing and decreasing. So these are the graph for non-uniformly accelerated motion. But for uniformly accelerated motion, graph will be a straight line because speed or velocity is increasing with respect to time. Anyone having any doubt?
Sir, can you repeat it?
This last one.
Yes, sir.
Okay, first tell me, what is the meaning of non-uniformly accelerated motion? What is the meaning of non-uniformly accelerated motion? Okay, what is the meaning of uniformly accelerated motion? What is the meaning of uniformly accelerated motion? That acceleration remains constant, yes or no? Acceleration remains constant. And if acceleration is constant, can we say that velocity is increasing? Yes or no? Velocity is increasing, and if acceleration is constant, that means change in velocity is equal for equal time interval. Yes or no? For uniformly accelerated motion, can we say that change in velocity is equal for equal time interval? But if there is non-uniformly accelerated motion, so sometimes acceleration is, let's say, 2 meter per second square, sometime acceleration is 1 meter per second square. Okay, acceleration may be negative, that is minus 1 meter per second square. Okay, yes or no? So sometimes if acceleration is 2 meter per second square, velocity is increasing. Let's say if acceleration is minus 1 meter per second square, then velocity is decreasing. Again, if acceleration is 1 meter per second square, velocity is increasing. Again, if acceleration is minus 1, then velocity is decreasing. So for non-uniformly accelerated motion, we can't say that graph is have a fixed shape or having a fixed value. No, graph can take any shape depending upon the value of acceleration, because here acceleration is changing continuously with respect to time. Yes or no? Suppose on a traffic, on a road, if there is a traffic, so sometimes speed is 10 meter per second, sometimes speed is 5 meter per second, sometimes speed is 0. Yes or no? Sometime you are applying a brake, sometime you accelerated the car. So accordingly speed is changing. Yes or no? Sometimes speed is increasing, sometimes speed is increasing at higher rate, sometimes speed is decreasing, sometimes speed is increasing with lower rate. So anything can happen here for non-uniformly accelerated motion. But for uniformly accelerated motion, change in velocity will be equal in equal time interval. So there is a straight line, but here we can't say any particular shape. Now clear?
Yes, sir.
Everyone, tell me, is this clear or not? Shubhanshu, is this clear to you? Okay, very good. So in first you can say the graph represented the motion of an object whose velocity is decreasing with time. Here graph represent the non-uniform variation of velocity of the object with respect to time. Velocity is increasing, decreasing, increasing, decreasing. Okay, okay. Now if we want to find the distance traveled by the body from 10 to 20 seconds, in the case of velocity time graph, which is uniformly accelerated motion. So how we will find? Anyone? That area under velocity time graph gives us the distance covered by the body, yes or no? Tell me. Area under velocity time graph will give us displacement or not, distance or not, yes or no?
Yes, sir.
That means we have to calculate the area from 10 second to 20 second. That means we have to calculate this area, and this is a trapezium. Yes or no? You can break this graph in two portions. So this is a rectangle and this is a triangle. So calculate the area of this triangle, then rectangle, and add these two areas. You will get the distance covered by the body. Yes or no? Okay. So this is your homework. Do this question at your home. Okay. And practice at least 20 questions on the platform from this chapter of this topic. That is from the graphs. Okay. Yes or no?
Okay, sir.
Okay, so this is the homework, and practice at least 20 questions on the platform. We will discuss this in the next class, and I will check and I will ask the answer from everyone. So everyone please solve this question at your home. Okay. Similarly, this is your next question, that from the velocity time graph we have to find the acceleration. Okay. So if we conclude today's lecture, first we studied about basic concept of graph, that is what are dependent and what are independent variables. Okay. Which quantity we generally take on x-axis, which quantity we take on y-axis. Then we saw distance time graph for uniform motion. Then we saw distance time graph for non-uniform motion. Then velocity time graph for uniform motion and velocity time graph for non-uniformly accelerated motion. Now in the next class, we will start with the equation of motion. But before starting the lecture, I will discuss the questions which are given to you today for homework. So please attempt those questions. Okay. So I hope today you learned something new and you enjoy the session. Okay. Okay. So thank you everyone. We will meet in the next class. Bye bye. Take care.